Hello, welcome back to Madison County, Kentucky. In the last video, we focused in on a section of the Big Hill Quadrangle. I'll zoom into that now. And we took one of the USGS DEM files and used that to symbolize the elevation and to add hill shade to show a little bit of 3D effect. We then zoomed in to a smaller section of that. We added roads, we added streams and reservoirs, added contours, and labeled everything, made kind of a fairly attractive map that way. So in this next video, we're going to zoom in even further. We're going to go into Pilot Knob much closer. Whoops, wrong one. Pilot Knob detail. And at this point, I'm going to turn off most of the DEM stuff, and at this scale, which we want to focus in and do some more analysis with Pilot Knob itself, but our resolution is poor at this larger scale. So what we're going to do is download some LiDAR point cloud data, and we'll go to the Kentucky GIS site, search on the term LiDAR, and we'll get the this is the choice we want, Kentucky LiDAR point cloud data. LiDAR is like radar, radio detection and ranging, except it's light detection and ranging using laser light. I will point out one other thing. The Kentucky GIS group has already taken the LiDAR data, which is less than a year old for completion of the state throughout, and they've made 5-foot resolution digital elevation models. We're going to start with the point cloud data itself. We need a couple of tiles for the area, for our study area. And the first one is right on Pilot Knob. It's N126E319, and I've already downloaded that. So we also, these are zipped files. What we need to do is use this last-zip.exe to unzip these files. I will mention the folks who wrote this software also have produced toolboxes with all of these things, all of the different things you can do with the program in the ESRI format. I don't use this enough and haven't used it long enough to actually want to well, that didn't do anything. There we go. We want to run it, and we'll get a screen that looks like this. Let's go to Browse, and we should have, where's my 319? There it is. All right. We can double-click on that, and we'll get it up here in this upper left window, and we'll have a blank square here. Now we go to where we want the output to go, and we need to specify the directory. I've had trouble recently when I specify the directory and then type in a file name. It all of a sudden enters garbage up in the directory, so I'm going to I'm going to type the file name first, and for the directory, push this square button here. This is kind of older terminology. This backstroke dot dot, double click on that. That moves you up one layer in the directory tree, and I'll go from there and pick what I want. And now I've gotten into the folder I want, and I'll say use current. Come back over here, make sure our file name is okay, and we want to decompress that file into a LAS file. So I say decompress, then I say start. And let's see, it looks like it's done. We get this message. The output is that file. Okay, I believe we got it. Alrighty, we can turn this off and turn this off and get back to here. We'll let's go ahead and turn off our. Okay, we'll just put the topo sheet back up there. So now what we have to do is take our point cloud data and make a last data set layer, or a new last data set, that is. So I'll go to my folder, right click, go to new, and I want a new LAS data set. And I will call it Pilot East. That'll be good enough. All right. And now I right click on that and go to Properties. And I go here to this tab, LAS Files. I'm going to go to Add Files, and it's I've been in this directory recently. So here's where's my, there we go, N126E319-3. So I want to do that. We'll open that. Okay. Now we want, well, we need to add that. No, I'm sorry, it's added. Okay, so we've got our file added to our last data set. We need to now go do statistics, and we'll calculate the statistics, and it gives the various returns. The first return would be the top of the tree canopy. The last return would probably be the ground. The program tries to use these statistics to estimate what is being measured at that. The ground is what we actually want. So we got that. That's okay. Now we go over here to our toolbox. And wait for it to open up. And wait. Okay. What we want is in the data management tools, right here, this toolbox. And we want the tool set called layers and table views, and we want to make a last data set layer. Alrighty, so our input data set is going to be the one we just made, Pilot East. So we're going to add that. And I'm going to choose class 2, which is ground supposed to be, that's the best guess as to bare ground. And we'll say OK. All right, you can see now that we've got something to orient ourselves, we can turn off the topo sheet, I guess. And this will eventually display as a bunch of points. It takes forever, and in fact we're not very much interested in that. What we want to do is now convert this to a raster, so we go back over here to, to conversion tools, and that would be here, conversion tools to raster, and the last data set to raster. There we go. And let's do that. Rather than opening the folder, which seems to put the entire point cloud data in there and not the subsetted one that we've just made, we want to use the pull down and pick that. And let's give that a name. We'll call it N126E319-2. And we'll use elevation. We use float as data type. Cell size. Let's make the sampling value 5 feet and say OK. All right. We can now, we don't actually need this this point data set anymore. We'll take that away. All right. So now we can symbolize this one. Let's okay, here it is up here. And we'll do stretched. Let's use the elevation 1 color ramp, and that should be okay. Okay, so there goes our best guess as to the ground returns of that. Let's do a hill shade for this as well. That's under the Spatial Analyst Tools, Surface. I've done a hill shade, there we go. And we're going to input our raster here, and we're going to call it, I may get a mistake here. Yeah, it's longer than 13 characters. So we'll have to shorten it. Okay, these okay, our azimuth 315, altitude 45. We won't accentuate, we won't have a Z factor. All right, and we should make this part, let's see, under display, let's make this about 50% transparent, and that gives us a fairly good looking thing. I'm going to turn off the hill shade just for the moment. And I've already done, we've only got part of our scene here, so I'll go ahead and turn on the other one, the N126E318, and you'll notice they don't really match up that well because the color ramp goes from the lowest to the highest on a given tile, and of course there's a lot bigger elevation change here. So what we're going to do is make a mosaic of these. And so this one is kind of buried You'll probably have to use the search function. So this is again under the data management tools. Whoops. Spatial analyst. Yeah, conversion. Where's data? There's data management. It's under raster here, and under raster data set there, and I'm going to say mosaic to new raster. All right, my input rasters are going to be 319-2, and here's the one I already had done, 318. My output location is going to be going to be, this is choosing this is kind of a pain. Whoops, that isn't what I meant to do. DEM2 add, that's the location, and the data set name I'm going to call pilot mosaic. Pilot mosaic. It doesn't matter if I spell it right, but okay. Spatial reference is optional. Cell size we want 5. Now let's see here. The number of bands is going to be 1, and the color map mode is optional. Let me well, let's save time. Okay, what's wrong with this? Maybe it's too long. Okay, we'll just call it Pilot Moss. Here we go. This is what I wanted to show you. This is an SRE grid file, so we have no file name extension, and it's one band, and we'll specify the cell size as 5. That is 5 feet, and we'll say OK. And now we have to symbolize that again. And symbology, stretched, color ramp, elevation 1, and OK. We can, if you kind of know how to do this already, but we'll go ahead and do it. We want, let's see, that's, need spatial analyst. There it is. Spatial analyst, we want to do hillshade. And the input raster is the one we just made. And take the defaults, say OK. Make it part transparent. Display 50% transparent. Okay, this looks pretty good. We can see a lot of detail now. That's a good bit better than the N44, which is starting to pixelate there. We can turn this one off and on quickly to see the difference. Oh, I've forgotten to turn those off. Well, never mind. You get the idea. And so that's all we'll do for this video, and now we'll take the next step where we're going to make a triangulated irregular network, a 10, and do some volume calculations on pilot knob. So that's all for now, and thank you very much.